All right, here we have the 2.2 lecture notes, limits, numerical and graphical approach. Again, a lot of text right here. We don't have to read all this. If you want to pause it, you can read it, or you can go ahead and take a look on D2L. Let's go ahead and start off with looking at a graph for a little bit of motivation for the idea behind a limit. So here we've got a piecewise function, and it is discontinuous. We haven't formally talked about what it means to be continuous, but intuitively speaking, a function is continuous if you can trace the graph of that function without lifting up your pencil. So if I start on the left and work my way towards the right, I run into a problem right here. I have to lift up my stylus. Similarly, if I go here, I run into another problem. It's a very different kind of issue. It looks very different, but it is the same, causes the same problem, and that is I have to lift up in order to continue drawing this. And again, over there, I have to lift up again. So there are three locations of a discontinuity. These three discontinuities we will look at in more depth later on, but for now, it suffices to say that these cause issues for continuity. So let's go ahead and work with these three locations separately. So for x equals 2, so at x equals 2, we can approach from the left of 2, and we can also approach from the right. And what do I mean from the left and from the right? Well, if we think about x equals 2 as being a location on a number line, when it comes to things that are one-dimensional, like a line, there's only one direction, and that direction's opposite. It's not like a plane where, like a surface, like a tabletop, where at a point you can move in a direction and a direction perpendicular to it, and then those two directions opposites. So a line is one-dimensional, so there's only one direction and that opposite, the negative of that direction. So here, at this location 2, we can either approach it moving left to right in this direction, or we can approach it from the opposite direction from the right to the left. So if we look at x approaching 2 from the left, let's go ahead and put a minus sign up here, just to distinguish we're doing in the x is approaching 2 from the left. Then what we see is, if we follow the graph, putting little direction markers on it, we see that the function approaches this particular y value, 4. So as we approach from the left, so as x approaches 2 from the left, f of x approaches 4. Similarly, if we look at from the right, so working our way this way along the x-axis, then the graph, we move in this direction. And we are approaching a value of 5. So we'll write it as x approaches 2, and this time we'll put a plus sign to denote from, we're working our way towards 2 with values bigger than 2. Then f of x approaches a value of 5. So clearly 4 and 5 are different numbers. And it's this discrepancy right here that the x's are going to the same location, but two different directions. But depending on your direction of approach, we arrive at two different values, which is strange. So that is the issue for this graph being discontinuous there. And what I've just described to you over here, these approaches, honing in on one particular x value, but the direction in which we hone in is different. these are two different types of limits. So whenever we do we'll go ahead and split here, look at two different things. This is called a limit as x approaches 2 from the left, and we're taking the limit of the function f so that we get 4. And down here, this is a right-hand limit. Approaching 2 from the right of f, this yields 5. Collectively, these two limits are called the one-sided limits. A lot of times, these two things will be equal to one another. These two numbers will match. For instance, if I pick any value to approach other than 2, 4, or 6 on this graph, literally any other value. If I pick this value, which I'll do in blue, right here, let's say this is 5, as we approach from the left and from the right, the y values approached are the same y value. It's when they don't match that can cause a problem. And in fact, looking at how I drew this second discontinuity, or sorry, this last discontinuity, even if we approach 6 from the left and from the right, we do get the same value for the limit. There is a distinct problem which we won't fully address in this video, what kind of problem this is. It's still a pointed discontinuity, but the limit, the left and right hand limits do agree. Okay.